My name is Mete ŞİŞMAN. Today I will be presenting LABSILENCE, an IoT-based real-time laboratory noise monitoring system built with an ESP32 MQTT and Node-RED. The problem is simple. Noise in laboratories reduces student concentration and research quality, and manual monitoring is not practical. LabSilence solves this with a fully automated pipeline from the sensor all the way to a smartphone notification. And the system follows a three-layer IoT architecture. At the bottom, the perception layer, the sound sensor, and ESP32 handles physical data execution. The network layer transmits data via Wi-Fi using the MQTT protocol to a local Mosquito worker. And at the top, the application layer, Node-RED, the web dashboard, and Telegram handles visualization and remote alerting. On the hardware side, a 4-pin analog sound sensor is connected to GPIO34. Three LEDs, blue, green, and red, on GPIOs 26, 25, and 27 provide local visual feedback for each noise state. An active buzzer on GPIO32 gives an audible alert every 10 seconds when the environment stays noisy. The noise measurement runs in 5 steps. First, 500 samples are accurate in a 250 millisecond window. Second, peak-to-peak amplitude is computed. Third, a noise floor is subtracted to remove the ESP32's ADC electrical noise. Fourth, the result is linearly mapped to a 0 to 100% scale. Finally, an exponential smoothing filter, 0.3 times the previous value plus 0.7 times the instant value, stabilizes the output and prevents false triggers. On the right, you can see the Mosquito Worker terminal showing the ESP32 connected and publishing data. And Node-RED runs two parallel flows. The first flow takes the noise topic and feeds it into the dashboard gauge. The second flow listens to the status topic when the switch node detects noisy, and a function node formats the alert, and the HTTP request node posts it to the Telegram bot API. The custom web dashboard connects directly to the Mosquito worker via WebSocket using MQTT.js. On the left, you can see the quiet state with a low gauge and blue LED indicator. On the right, the normal state with a moderate gauge and green LED. And here is the noisy state. The gauge reads 92%. The red LED indicator is active and the alarm panel appears in the bottom right corner saying noise threshold exceeded. And now let me show you the system running live. And in this video I will walk you through three states on the dashboard, and I can show you the physical hardware, the breadboard, ESP32 and LEDs, as you can see. And first I set the environment to normal. The dashboard shows a moderate noise level and the green LED is on. And then I make loud noise and you can see the gauge jump above 45%. The noise state is triggered. The red LED turns on and the alarm panel appears on the dashboard, as you can see. Finally, when I stop, the environment becomes quiet again. The gauge drops below 8% and the system switches back to quiet. The blue reds turn on. And on the left you can see the Telegram notifications that were delivered during the noisy period, each arriving within 2 to 3 seconds. The test results table on the right confirms the system's performance across all the scenarios: silent room, normal speech, and loud noise. And to conclude, LabSilence successfully demonstrates a completed IoT monitoring pipeline using low-cost open source components. The main limitations is relative calibration of the analog sensor, and future work includes a calibrated decibel sensor, database logging, multi-node monitoring, and an OLED display. Thank you. I am happy to take any questions.